Hello, and welcome to Chapter 2, Section 5. So we finally moved on from chain rule. Today we talk about implicit differentiation. So first, implicit is, I'll talk about what that means. Differentiation, we're just finding derivatives again. Okay, so all the derivatives that we've been finding up until now is actually in explicit form. So explicit just means like it's always y equals whatever our equation is. So that's what we've been doing up till now. So now we're going to change it up and do implicit. Implicit just means your x and y are on the same side of the equal sign. And like usually made so that like you can't get y by itself very easily. Like this first one, xy equals 1. Yeah, we could just divide both sides by x. Or we could just do it as, find the derivative as is, like this. And so depending on the equation, sometimes it's easier to change things around so that it's more in the form that we like. Sometimes it's easier, like for this one, x squared plus 3y squared equals 9. It would be really difficult to make it look like explicit form by solving for y by itself and then finding the derivative from that. So this is a case where like, let's just do it in implicit form. Okay. So first, let me give you an example of explicit form again. So just a quick reminder, when we did explicit form, let's say we were using the equation y equals 3x squared plus 5x minus 12. Remember, another way to write like the derivative of y is just y prime. So we're going to continue with that. So that we would end up with this using the power rule. So the exponent of 2 would multiply to the front to get 6x to the first power, and then the plus 5. The minus 12 is a constant, so the derivative is 0 for that. And then this would be it for explicit form, if we were finding the derivative of something in explicit form. So implicit form, I'm going to do with the xy equals 1 equation. So first, the xy here technically is being multiplied, right? Because it's x times y. So we would need the product rule. So what we're going to do is find the derivative of each, the x and the y. Derivative of x is just 1. Derivative of y is also just 1. If you're thinking about it as a variable, y is just like 1y. So the derivative would be 1. But because it's a y instead of an x, anytime we've been finding derivatives, it's always in relation to the variable x. So now that we're doing y's, it comes out slightly different. So y, the derivative is still 1, but then we also have to multiply it by y prime. So it's kind of like what we did before, where we said, okay, well, the derivative of y is y prime, because I was technically still finding the derivative of y there. We just didn't really think about it back then. And so now we actually have to deal with it. And so it's still going to be y prime multiplied by 1. 1 is still y prime. So, and then on the other side, moving on with the product rule, we're going to do our cross multiply thing. So we end up with 1 times y is y plus x times y prime, because I have the x times the 1 times y prime is still xy prime. And then on the other side, I have that equals 1 there. The derivative of 1, since 1 is just a constant, is 0. So this just equals 0. So we found the derivative so far. We're just not done yet. Our goal is to get y prime by itself, because our final answer should be like y prime equals whatever to find a derivative, right? So we're still going to do the same thing here. So I'm going to subtract y on both sides of the equal sign. That'll give me xy prime equals negative y, and then divide both sides by x to get y prime by itself. Okay. So my final answer is y prime equals negative y over x. So you can see how this is slightly different then of what derivatives we're finding, because now since x's and y's are mixed together, our final answer is also going to have x's and y's mixed together. So basically, the whole point of implicit differentiation is that anytime you take the derivative of a variable other than x, you have to multiply that variable, like when you take that derivative, you have to multiply by y prime, or whatever other variable, whatever other letter it is. So if it's like t or whatever, t prime. But you have to use it. All right, so let's do another example. This time I've got y cubed plus y squared minus 5y minus x squared equals -4. So very clearly, there's no way we can isolate y and do this in explicit form. So we would have to use implicit differentiation for this. So looking at this, I've got 3 different places where I'm going to be taking derivatives of y's. So in my head, I need to remember, okay, I need to use y primes for those. But then here, when I'm just finding the derivative of -x squared, I don't need that whole y prime thing. Okay, so first, we'll start with y cubed. Y cubed, the derivative would be 3y squared. But then because it's a derivative of a y variable instead of x's, we're going to multiply by y prime. Okay? And then for the y squared that comes next, I have the plus sign. Y squared, the derivative is 2y because of the power rule. And again, it's a y variable, so I have to multiply by y prime again. And then with the minus 5y, the derivative is -5. And even though my derivative here doesn't include a y, I still have to use y prime because the original minus 5y had a y in it. So also need to multiply this by y prime. And then I have the minus x squared, so now we're dealing with x's only. So I find the derivative like normal. So minus x squared, the derivative will be minus 2x. I have the equal sign. -4, the derivative is just 0, because -4 is just a constant. Okay, so remember after we find the derivative, include all the y primes, then we want to get y prime by itself. So first, I'm going to move that -2x over to the other side of the equation. That way, I don't have to deal with that here. So I have 3y squared times y prime plus 2y times y prime minus 5 times y prime equals positive 2x. Okay, so now I have 3 places where y primes occur. I need to isolate it, just have one. So I'm going to take out a greatest common factor of y prime, because if I do that, then it puts it in just one spot, because factoring out a y prime from the 3y squared times y prime leaves me with just 3y squared plus, and then the 2y times y prime, the y prime will come on the outside, leaving me with just 2 plus 2y, and then minus 5 equals 2x. Okay, so because I have that y prime on the outside now, and there's only one of them, now it's a lot easier to get by itself, because at this point, I can just divide everything by 3y squared plus 2y minus 5 on both sides, and then that'll get me the y prime by itself. So my final derivative is going to be 2x over 3y squared plus 2y minus 5. Yay! That's it. Okay, let's try a slightly more complicated example this time. So I've got 2y to the 4th minus y cubed x squared equals 5 minus 4x cubed. Okay, so just going term by term here. I've got 2y to the 4th, so that I can just find the derivative of y, which means I need a y prime, but the derivative of 2y to the 4th is going to be 8y cubed because of the power rule, and then I'm going to remember to multiply by y prime. Alright, then my second term I have minus, I'll leave the minus there, y cubed times x squared. Ooh, y cubed times x squared, because they're multiplying, means I'm going to need the product rule. So let me just give myself some more space here so that I can do the product rule. So y cubed, the derivative is going to be 3y squared times y prime, because that y prime needs to be there because I'm taking the derivative of y cubed, not like x's. Okay, so 3y squared times y prime. The derivative of x squared is still just 2x, and these are x's, so this is fine. Okay, so I'm going to do my product rule in parentheses, just so I remember there's that minus sign in front of all of it. So, using my product rule, I'm going to have 3y squared times y prime times x squared plus y cubed times 2x for my little cross multiply thing. Okay. And then on the other side, I've got the equal sign. The derivative of 5 is just 0 because that's a constant. Minus the 4x cubed. These are just x's, so I just find the derivative like normal. So this will be 12x squared using the power rule. Okay. Let's simplify this out a little bit. So I'm going to distribute and multiply stuff out. So I've got this minus that needs to apply to both of those terms inside the parentheses. So it'll end up, I'm going to multiply like, basically just leave the y prime at the end just because it's easier to see. So the 3y squared I'll multiply with the x squared to become 3x squared, y prime. Oh, not plus. It'll be minus because I'm distributing the negative sign. 2xy cubed. I like to put my letters in order alphabetically. Okay, equals negative 12x squared. Alright, so again, I'm trying to get y prime by itself, which I have y primes here and here. So I want to add the 2xy cubed over to the other side. And then I'm also going to factor out that y cubed. Or sorry, y prime, not y cubed. So factor out that y prime will leave me with 8y cubed minus 3x squared y squared. Okay? So now to get y prime by itself, we just need to divide both sides by whatever's in the parentheses. So we're going to end up with y prime equals negative 12x squared plus 2xy cubed over 8y cubed minus 3x squared y squared. That's it. Okay, moving on to another example, even more challenging. So this time, rather than just finding the derivative, we also need to find the slope. So this is the same steps as before. Whenever we needed to find the slope at a point, we just needed to find the derivative and then plug in the x value to find the slope. But now, because we're going to have x's and y's, we have to plug in both x and y values for the point. Okay, so that part I'm not too worried about. We'll do that at the very end. So what we need to focus on, though, is finding the derivative of 3 times x squared plus y squared raised to the second power equals 100xy. Oh my goodness. So first of all, here, I've got parentheses, which means I'm going to need chain rule. And then the second half of the equation, I've got multiplication, so I'm going to need product rule there. So here we go. Let me rewrite this bigger so I have lots of space. Okay, let's start with the chain rule. I've got the inside stuff is going to be x squared plus y squared. The outside stuff is going to be the 3 stuff in parentheses squared. Okay, that part's not so bad. So then when I find the derivative of the outside multiplied by the derivative of the inside, derivative of the outside is going to be 6 times the stuff in parentheses raised to the first power because of the power rule. Remember, the stuff inside the parentheses stays the same. So the stuff that I had on the inside was the x squared plus y squared. So that stays the same, and then I'm not even going to bother with that first power because why do I need to write it? And then we're going to multiply by the derivative of the inside. Well, the derivative of the inside is x squared plus y squared, so the x squared will just be 2x. We have a plus sign. The derivative of y squared is 2y, but then because we're dealing with the y variable, we'll need to multiply by the y prime. Okay, not too bad. All right, moving on. So that is the derivative of everything on the left now. Equals 100xy, the derivative of that we need product rule. So I'm multiplying 100x with y. So for the 100x, the derivative is just 100. For the y, the derivative is just y prime, 1 times y prime. So product rule with that, I'll end up getting 100x times y prime plus 100 times y. Okay, not bad. I'm just gonna simplify by multiplying some stuff out. Oh, I also need parentheses around this because that was the derivative of the inside right there. Okay, so I'm going to distribute some stuff from the left side. I can distribute the 6 to get 6x squared plus 6y squared. That's being multiplied with 2x plus 2y prime. Okay, which means on that side, on the left side, I'm going to need to FOIL. Alright, so 6x squared times 2x is 12x cubed. 6x squared times 2y prime is going to be 12x squared y prime. And then 12x y squared. Sorry, I'm really lazy. I'm not going to edit out the bell, just so you're aware. And then plus 12y cubed y prime. Okay. Whew. And then all the other stuff on the other side. Okay. So at this point, I've got everything like multiplied out. I can just get all my y primes on one side, everything else on the other. So my y primes are here, here, and here. So that's all the stuff that I want on the left. I just like on the left. You can move it to the right if you want. And then the other stuff I'm going to subtract over to the other side. So I'll end up with 12x squared y prime plus 12y cubed y prime minus the 100x y prime. And then on the other side, I have the 100y. I'm going to subtract the 12x cubed and subtract the 12xy squared. Okay. Then I want to get the y prime factored out. So then finally, I can divide both sides by the stuff in parentheses to get y prime by itself. So we have the derivative now. But our original problem was to find the slope at the point 3, 1. So that just means we need to plug the x and the y values of this point into our derivative, and that'll give us the slope. So y prime, or our slope, is going to be 100 times y, which is 1, minus 12 times our x, which is 3 cubed. So simplifying this down, I end up with a reduced fraction of 13/9. So that's the slope. Did it. Okay, that's all I got for this section. Thanks for watching. Bye.